All right, so this is question number 8, yes, that we are now going to do over here. It says a concave spherical mirror has a radius of curvature of magnitude 20.1. So radius of curvature is given, which is 20.1 centimeter, right? Okay, consider the case when the observer is on the same side of the object and the object is brought in from a large distance. I'm trying to bring up the object from a large distance towards near to the mirror, right? That is from the left. Okay. For each of the locations of D naught below, determine the following, right? For questions like this, you know the radius of curvature, right? So now you're bringing it your object from here at some location, probably 40.2, then 20.1, then 10.1, and then 7.7, right? There are four different locations at which you are trying to bring in the object. So first thing that you would need to know for these questions is you need to find your focal length, where it does exist, right? So that you understand where am I standing right now. So the good thing is that they have given you the radius of curvature, right? And in the example number 9, we know the formula for the radius of curvature. So radius of curvature formula is basically nothing but twice of the focal length, right? So our curvature is 2f. So I'm going to say my radius of curvature was 20.1, so it's going to be 2f. So my focal length would be just 10.05 centimeters, right? Okay, so we got our focal length, which is 10.05. Uh, so over here, we can see that I'm way beyond in the first part, which is 40.2. Then I was reaching till near, which is 20.1. Then we got 10.1, which is exactly at the focus. Yep, that's a verification that our focal length is right. And then we got D 7.7, right? So just remember the value of the focal length right now. We are going to use it in order to solve some questions later on. Okay, so I forgot the radius of curvature. Only I need is the focal length right now. All right, so for the first part, part one, you need to tell that what is your image distance. Then you need to tell which type of image is there, like real or virtual. Then the orientation, upright or inverted, or magnification factor, right? So for the first part, I'm going to use the same formula that we know. It's 1 over distance of object plus 1 over distance of image. That should be equal to my 1 over focal length, right? So for the first part, the object is at a distance of minus 40.2. The image is already at the location I would say. And the focal length we just calculated is 10.05. Alright, for this part, let's calculate the distance of image. It turns out to be, right, so once I did the reciprocal, it turns out to be distance of image is minus 13.4 centimeters. Now try to add that as a minus 13.9 centimeter, but if it didn't work, just put the positive 13.4, sorry, 13.4, not 9, because distances are always in positive direction, right? So it's a 13.4 centimeters over there. Right, so the object is at 40.2. The image turns out to be on the opposite side at 13.4. So what type of image is that which is opposite to the lens? It's a real image. So your type of image answer would be a real, right? Okay, so once it's on the other side, it will be opposite and it would be inverted to what it is actually over here. So the orientation over here would be inverted. Last but not the least, we have to calculate the magnification factor. So for magnification factor, we know that m can be calculated with the height of the object and the image or the distance of the object and the image. So for in this question, we are only given the distance. So I'm going to use the same formula, which is distance of image over distance of object. So negative distance of image turns out to be negative 13.4. Distance of object turns out to be negative 40.2, which will give me an answer of, right, so I'm getting minus 1 over 3, or you can say minus 0.3333 as the magnification factor. So since it's getting real, it's getting inverted, it's also getting diminished, right? It's reducing its height, whatever it is initially. So I have a negative magnification factor, which is 1 over 3 or 0.333. That's the answer for your magnification for this part. Right. So once we are done with the first part, let's now try to solve it in the same manner for the part 2. We have different distance. I'll clean it up first. Alright, so for this part, we have the distance of object at 20.1, right? So I'm going to use the same formula again to calculate the value for distance of image now. So 1 over distance of object plus 1 over distance of image, which will be equal to 1 over focal length. I would say the distance of object now is minus 20.1. Image distance, I have to calculate that, and focal length would remain same. So from here, the image distance turned out to be negative 20.1 centimeters, right? So like always said, if try to put it as negative 20, if it doesn't work, just try to put positive because the distances are in positive. All right, now talking about the type of image, it's again beyond, like the focus point is 10, right? So it's still over here, somewhat at 20, right? Uh, somewhat at 20, right? Object. So if you are at 20, you are still behind the focus point. It's still gonna be on the opposite side, somewhat over here, and it's, or maybe, yeah, somewhat over here, and it's still going to be inverted, right? Because in the other side of the image. So DI answer would be negative 20.1 or just 20.1 centimeters. The type of image is still a real, and orientation is still inverted. Now the last part for this question is about the magnification factor. So for M, I have to calculate again the same formula because I know the distances. So DI, image distance, over D out. The image distance turned out to be negative 20.1 divided by the object distance, which turns out to be, what was that? Negative again 20.1. So yeah, and there's a negative sign in the formula. So I'm getting an answer of negative 1 as the magnification factor, right? So it's being reduced to a factor of minus 1. You can say that's an answer for magnification. All right, so with that being said, these were part 1 and part 2. Now we're going to solve for part 3, at which we are actually located on the focus. So if we are located at the focus, there would be slight change um, in the things, right? So since we are located at the focus, whenever there is an object that is located at the focus, what will happen to the image? So by theoretical knowledge, I know that whenever I am at focus, my image would go to infinity, right? It will go to infinity points, right? So I can do it something like this. 1 over f is equals to 1 over di plus 1 over do. Since I know that focal length is basically my object distance, right? So this is my object distance, which is exactly the same at the focal length. then I would say that my 1 over image should give me a 0 answer. And that means that the DI is basically at infinity. So whenever the object is placed on the focal length, your image is going to be produced at the infinity, right? So I think yeah, I think there's no need for any calculations in this part of the question. In this part of the question, I think there's no need for any calculation. So you can say the image distance is basically at infinity, right? Right. So when you have an infinite image, your type is always going to be a real, and it is also going to be inverted, right? Value for m. Now that's a good question. I'm not quite sure how can you calculate a infinite image magnification factor, but what I can comment over here is that magnification factor for infinite is much, much greater than, like, it can be 1000 because it's going at infinity, right? So the example for such cases is that when you have a spotlight and you're when there's some new opening of some shop or something like that, they usually place a spotlight outside their shops and they throw the lights in the air and you can see the lights going up way beyond the skies, right? So that lights has a bulb which is focused at a focal length and the rays are going to a distance of infinity, right? So magnification factor is very huge for that thing. So you can say greater than one, try to plug in 1000. I'm not really quite sure what value do I have to plug in over here. It's m. If your answer infinite, put infinity. Maybe try to put infinity over here, but let's just check it a couple of times. It's gonna be a huge number, and you cannot calculate that. All right, now we are left with just one last part over here, which is about the D out for the last one. So for the last part over here, I'm gonna say that D out is basically what? It's 7.7 centimeter, which is now I'm closer, lesser than the in focal length. So I can say that D out is basically less than the focal length. Now the image that I'm gonna take is going to be virtual for sure because I've moved near the focal length. Type of image would be not real, but it's gonna form on the same side, so it's a virtual image now. And one more thing that I also can conclude, once is the virtual image is going to be upright, right? Not inverted. So all three parts first are inverted. The last one is upright because I have moved more further apart from the focal length. For calculations, I'm going to say it's a minus 10.05 focal length. The distance is minus 7.7 plus the distance of image. So that turns out to be 1 over minus 10.05 plus 1 over 7.7. So your image distance turned out to be at 32.929 centimeters. You can use that as an answer over here. For your magnification factor, that's again going to be 1 over di over d out. So your distance of image is basically minus 32.929 and your what's that object distance is what? Minus 7.7. So the magnification factor will turn out to be minus 32.929 divided by minus 7.7. So your magnification factor is turning out to be positive number in the answer first thing, and it's turning out to be 4.27649, right? It's a positive number. So magnification factor is positive, which makes sense because it's now on the same side. It's a virtual, now it's upright, so it will increase. Also, it has moved from the focal length towards the lens, so there would be magnification over here, and the image would be virtual. For exactly at focus, it's gonna go at the infinity. For beyond the two, like way behind the two focal points, it's gonna be somewhat around that you have to calculate using the formulas that were given over there. Try to put the answers and let's see it works. If it doesn't, just let me know. I'm gonna quickly review it and then get back to you on it. Right. So that was question number 8.